Hello guys, my name is Arun and welcome to my channel. This is a series of tutorials on Python hacks, wherein in each tutorial I'll be talking to you guys some interesting concepts and some advanced concepts in Python in a non-linear manner. Okay, in today's tutorial I'll be explaining to you guys about an interesting feature available in Python called as weave. Now, what is it? Before I tell that, let me give you guys a small introduction about what Weave is and how it's done. See, as of now, SciPy has this module called as Weave. Okay. Now, this is the functioning of this module is as follows. Now, if you have a C code, let's say a short C snippet, let's say, and you want to include that function or a function that you defined in C into Python, okay, either you have to convert it into a Python code, or you have to find some kind of a bridging mechanism or a bridging software to do the same option. Now, Weave helps you to be the bridging option. What it does is as follows: you can write your C code directly inside Python, and your Weave module is capable of understanding what's happening and takes the code and directly converts into a easy to do machine code that becomes an integral part of Python and works as it is. Now, you guys might not understand exactly what I'm talking about right now, but you'll follow with me. But just follow with me, you'll understand clearly. Okay, now let's go to the example, and you guys will understand what's going on. What I'm going to do today is, just like in one of my previous tutorials, I'm going to use the classical matrix multiplication, and I'm going to show you guys how good it is, how good the operations go by when we use matrix multiplication. So with using weave and other stuff, I've included a numpy module for defining the matrices, time module for finding the time elapsed options, and then I've imported the weave module from SciPy, and with this line over here. I define three variables with certain values for defining the sizes of the matrices, and I'm creating three matrices based on these sizes on the top, and I'm making them empty, and then I'm assigning A and B to be have random values generated using the random function in numpy module. Simple as that. Now here comes the interesting part. This is actually the interesting part. Now, here's the thing. What you have to do is that if you want to include a certain function a certain function in Weave, it's using Weave that is written in C program or C++. This is as follows. First rule of order: create a function. The function can have any name, doesn't matter. And then what you do is that write the function arguments in the function arguments, like all the values that go in, go out, doesn't change, doesn't matter. Just write the variables that you want to give the function as an input, which it can be modified as well, doesn't matter. Okay, first thing. Second, what you do is that open a string called as code. I mean, it can be anything, doesn't matter. You just open a string, and within triple double quotes or triple single quotes, write down your C program. Write down the C code as you would write in your C file, exactly over here, and simple as that. You don't have to worry about the header files and everything. The first thing you have to keep in mind is that you just have to include. There are a few things that the C code should have. First of all, it's local variable declaration. What I mean by local variable declaration is, suppose if you're using certain variables inside this code snippet, all those variables have to be defined. Like for instance, like the variables like mat1, mat2, and rest, these are actually passed to the Python function. These need not be defined, no problem, because The function knows, the C code here will know because of V that these are already defined, so doesn't matter. You don't have to worry about it. So that's not defined. You don't have to define that. Second, but all the variables like I, J, K, C1, R1, C2, something like these have to be explicitly defined for C to work with C. Okay, and that's what I've done over here. In this line, I'm defining I, J, K, the iterating variables, and R1, R2, C1, C2 to denote the rows and column number of rows and number of columns of the input matrices mat1 and mat2. And next thing is, what wave does is that when you pass arrays into it, wave is capable of understanding how numpy arrays work. As a consequence, when the program gets executed, weave builds certain bit of macros on the top and generates a lot of variables on the top before executing the actual code in the pre-process stage. And what it does is that it creates certain size variables like these. Now nmat1 is actually a size variable, and similar to nmat2 is also a size variable. Now let me tell what's happening. Now mat1 nmat1 is actually the size variable for the input variable mat1. Okay, so let me write this in C comment. Dimension variable for mat1, and similarly this is dimension variable for mat2. How do we find it? It's simple. Look at the function name, look at the variable name, and next to it just write a capital N on the leftmost end, and that's it. And that is actually your function name. Simple as that. That is actually your the size dimension variable for your input matrix. Now what it does is that in this since this in this input array mat1 is two dimensional, you have this value nmat1 has two values, 0 and 1. The 0 stands for the 0 value holds the number of rows and 1 holds the number of columns. Suppose if we have if you have a 5-dimensional arrays, then you'll have nmat1 will have like 5 values, 0, 1, 2, 3 and 4. Okay, like that. And then what I'm doing is row 1 is actually the number of rows in matrix mat1, row 2 is the number of rows in mat2, C1 is the number of columns in mat1, and C2 is the number of columns in mat2. Fair enough. And then we go to the actual execution of the loop. Actual execution of the loop is exactly your C program code. Like if you were to do a matrix multiplication in C, you might know how to do it. You're going to do the exact same thing over here, but with the slight corrections. You do not all the way after you pass these variables, when you use these variables inside the code snippet, first thing is write them in capitals. First rule. Rules. Write input variables in uppercase. If they are already in uppercase, you just follow the same notation and add 2 to the name. What I mean is, see, mat1, when you want to access mat1, what you do is write the entire name in capital letters and uppercase, and then after the actual name, like this is mat1, so the modified name in the C part will be mat1 2, whereas this 2 over here is actually an addition. You have to keep in mind while you're working with V. Okay, this is actually not this is not strictly speaking the variable mat1, but it's actually a macro which is actually made to make sure that some processes happen faster in we're calculating the values. What happens is that these are actually Python variables, and these are actually C variables. So you're actually communicating between C and Python during these processes. So what you need is that you need some. So what happens is that some macro variables are created. Like these two are actually macro variables that are in the border of C and Python, and they communicate by taking inputs from both sides. So these are actually not the actual variables, but these are actually the macro variables that are in the border that access variables. So what you do is that you just have to write the input variables in uppercase when you use them, and then add 2 to the name at the last. So res becomes res in capital with the 2 at the end. Mat1 becomes mat1 with 2 at the end, and mat in capitals, like that. Second thing is that uh, use use curly braces instead of the square braces for indices. That's the second correction you have to keep in mind. Like where if you were to write if you were to if you were to access these variables, some particular element, like for some particular element of I comma j in res2, usually you'll go with square brackets like these in Python, and even in C you used to use the same thing, but for weave you just have to make a small correction, and you should not use this. Instead you have to use circular braces, round braces, like these. That's the two corrections you have to keep in mind. Other than that, the program is exactly like C. And what you do is that once you write this entire code inside triple double quotes or triple single quotes like this, and this is the magic line you have to keep in mind. This is the ultimate line. What it does is that you just call the v function, v module, and then in that there is this, I guess, function or a handle, I guess, called as inline. And then what you do in the inline is that you just pass the code string, the entire code string, and then in the next variable called as arg underscore names, you write in single quotes what are the actual arguments that you're passing to the function. Okay, once you do that, and that's it, your v part is over. Now we just have to now when you run this program, and whenever you execute v, what will happen is that this part will be executed and made into some equivalent Python function, but which works at the more or less the same speed as that of C, and then it will work nicely. So how do we call it? It's simple. Now I just wrote the Python stuff at the bottom. A weave call at the bottom. It's extremely simple. What you do is that just call matmul underscore weave, the same function, and pass the variables. Simple as that. Now if you want to return a variable or something like that, what you can do is that at the bottom you can write return res, something like that, so that you can return variables. So it's not a problem. I defined this in such a manner that the variable gets modified inside the function, so it's nothing to worry about it. But if you want to have return statements, it's fine, it's not a problem. So this is the actual matmul v part. And then what I've done is that I've used the same matrix multiplication using the highly optimized function np dot product function in numpy to do the same matrix multiplication. This function time in the module time, when started just clocks in the time taken, clocks in the time difference between some reference point till the current point when the code is executed. So it just marks that time. And so So the same thing is done over here. So what you have is that if you just subtract the stop value and the start value, you will get the time taken in seconds to for this process that happened between these two to take place. Okay, so what you'll get is that this is like a start timer, this is like a stop timer. So if you take the difference, you'll get to know how much time it has taken for the code in between these two statements to run. So that's what you get. So you'll get when you print this, you'll get like numpy took something like 15 milliseconds, something like that. Okay, and similarly, this is the implementation of the matrix multiplication in pure Python. In pure Python using loops for loops, and then this is actually the weave call which I've done at the bottom. Now to execute it, it's fairly simple. Let me clear this up. Okay, executing this is fairly simple. And by the way, just one important thing, as far as my understanding goes by, I guess weave is not available for Python 3. It's in SciPy. Let me put this in a proper way. Weave is not a part of SciPy yet in Python 3, but it's an inclusion in SciPy in Python 2. Why is it like that? I'm not sure. Maybe in the future versions of SciPy they might include Weave a part of it, but as of now, Weave is not a part of SciPy in Python 3. But but I think you can install this separately. But other than that, all the operations we are doing so far, they're applicable to both Python 2 as well as Python 3. But I'm running now I'll run this in Python 2. Running this in Python 2 is just like any program. You just have to type Python and then your function, your program, press enter. What will happen is that during the first time it will just execute the function. Okay, let me just scroll this up so you get a better view. Okay, this is where we launch the function, and the numpy took like 0.16 milliseconds to do the entire matrix multiplication. That's obvious because numpy is fast. That function is extremely fast. And then you have the Python operation which took like 46 milliseconds. Okay, and now this is where the file is being compiled. And it says that there are a few warnings like mat1 where some variables are not used, and even this variable is not used, so it's not a problem. And then at the bottom it says that we took 912 milliseconds to take place. Now you guys might kick me like, hey, why the hell, like Python took like 0.16, how come Weave took like 912 milliseconds? It's not even helping. Well, the thing is, first when you run this for the first time, okay, it will take time because the program has to be compiled, so it will take the first time. But when you run for the second time afterwards, it will be faster. Now if you look at this right now, this answer right now, it says that numpy took 0.22 milliseconds, whereas we took 2.27 milliseconds. Now that's a phenomenal jump from 912 milliseconds to 2.2 seconds, 2.2 milliseconds. That's a phenomenal jump. Thing is, though I'm using C program, it's not faster than numpy. First you have to keep one thing in mind. Now for matrix multiplication, I've used this np dot function, which is extremely and highly optimized underneath. It uses a highly optimized code underneath. As a consequence, numpy functions are super optimized. So they are actually well. But on the other hand, if you were to use the numpy values and define your own function and something like that using numpy matrices and stuff, they will not be faster. They will not at all be fast. Okay, so in those cases, Weave works very well. And if you know C and if you want to implement in the C structures, and not C structures, some C functions in Python, it's good. This will be really good. Okay, and that's the thing. On the other hand, if you were to do on the other hand, like if you were to do the same operation, if you want to do some more complicated operations, then NumPy may not be faster. In that case, Weave can pick up the speed and pick up the speed. So that's about it. So if you run this again, you're getting a fairly consistent value saying Weave is taking like 2.25 milliseconds for this matrix multiplication to take place, and that's about it. And that's about it. Uh, you can do the same thing in You can do the same thing in using Python 3, but for that you just have to, this line won't work for Python 3. Instead, you have to install Weave separately in your Python. I haven't tried how to do that in Python 3 separately, but once you do it, you can just directly use import Weave, and then all the other procedures are exactly the same. And that's about it. Thank you guys for watching. Hope you guys found it really useful and interesting, and I'll come up some other time with some other interesting video. Till then, take care.